Number 30. Let's talk about this one. It's a little tricky. Then I'm going to teach you another something real quick to finish this section for you. Number 30. Number 30 is a b of x is equal to tan x or radical 4 minus x squared. Okay? X squared. Now this one has two discontinuity. Can you guys get involved? This one, tan x has discontinuity and radical has discontinuity. Could you do me a favor and tell me, guys, how you find this domain? We want to find a domain. Here we have to find a domain. Domain of a tan. Domain of a tan x. Anybody remember domain of a tan x? Look. Tan is a sine over cosine. Cosine is a 0 on a pi over 2 and negative pi over 2. And that is a graph of a tan. That is a graph of a tan. Tan is discontinuous at negative pi over 2 and pi over 2. Tan is discontinuous. Let's draw this. Let's draw this. So let's say, what is a pi? Pi is a 3.14 is 1.5. This is a pi over 2. It's a negative pi whole and whole. Negative pi over 2. These are the discontinuity for a tan. And then this guy, anybody remember from the previous classes, how are we going to find the domain of a radical? Anybody, give me some, give me some, give me anything, give me anything. Very good, you're right. This one I have, this is the one I have, is in the review section, chapter 1. I'm going to do it really, really quick for you. This function, negative infinity and positive infinity, that would be 2 minus x times 2 plus x. We want to be greater than 0. That would be negative 2 and positive 2. Okay? This is the way you do it. I'm going to do this fast. I want you to pay attention to it, please. Please pay attention. How many interval I created for you here? How many interval I did create it for you? How many?
3.
3. Very nice. 1, 2, 3. Give me a number from this region. We're going to do this later in chapter 4 also. Choose a number less than negative in this region, less than negative 2.
Negative 3.
I'll write it for you so you don't get confused when you go home. What is negative 3 squared?
9.
What is 4 minus 9?
Negative 5.
That's a negative. I want the positive. Greater than 0 is not negative. We want positive region. Go on to Google today after this class. Tell them that find the domain of a radical for me. They will teach you this all over. No, we don't want negative. We want positive. Choose a number between negative 2 and 2 for me. Watch the board.
0.
Watch. 0. What is 4 minus 0? Positive or negative? Positive or negative? Positive. Very good. So we want that region. Yes. Choose a number greater than 2, 3. 4 minus 9 is a negative. No, we don't want that region. We want only the domain of a radical. Domain of radical 4 minus s squared is from negative 2 to positive 2. I'm not done with this yet. If some of you know it, don't say anything till I'm done. That's a domain of a radical. That's a domain of a, what do you call that? Tan. Okay, tan. Talk to me. Talk to me. Talk to me. Write it down and I'm going to ask you a question. Talk to me. I'm going to ask you a question. All right. If you miss a class today, how are you going to catch up? This is important. This is hard, some part of it. There's a good review of it from previous one. I want to ask you a question. This is negative 2 included because the denominator is not included anymore. So we have to write negative 2 and 2 because it's a denominator. You see my point? The endpoints are not included. Make the denominator 0. Am I making sense? I explained to you. And -2 is right before negative pi over 2, and +2 is right after 2. This graph is absolutely beautiful, and this is book doesn't show this. I show it to you. You understand me. Now write the domain of this function. Domain of a function b of x, domain, let me do this. Domain of a b of x is -2, comma, okay, -2, comma, negative pi over 2, union, negative pi over 2, comma, pi over 2. I need more room here. And union, pi over 2 to 2. Here we go. That's the domain of it. I explained everything to you perfectly. So this function is not continuous. He says, explain using the why the function is continuous at everywhere and its domain. State the domain. I state the domain for you. I state the domain for you. So this function continuous on this domain, on this domain. Anything else is not continuous. For example, here is not continuous. On these 2 points is not continuous. Here is not continuous. Okay, I'm going to write this for you. I'd like to write it. Is it continuous here? No. Is it continuous here? Yes. Is it continuous here? No. Is it continuous here? Yes. Is it continuous here? No. Is it continuous here? Yes. Is it continuous here? No. No. Yes. No. Yes. No. Yes. No. Here's a good one to write it for you. What do you think? That was a tough one. That was a hard one. That was a tough one. Robbie, you made it. You made it half.
Yeah, sorry. I had to pick up my lab stuff for chemistry.
For Kemi, come on, Robbie. You don't hurt my feeling. Math is important. Math is the mother of all sciences. Math is the mother of chemistry. Mommy is more important than a baby. Mommy. Okay? Okay, I'm going to make sure you're here. Okay?
Thank you.
You're welcome. Yeah, this is important, Robbie. It's very, very hard section. Don't miss it. All right, guys. One more thing I have to teach you. One more thing I have to teach you. Okay. And I have everybody here today after Robbie decided to join us. Here we go. You want to write it like a book or you want to write mine? It's up to you. It's called intermediate value theorem. Is a continuation of algebra. It's funny. In pre-calculus yesterday, I did teach intermediate value theorem. Here we go. This is intermediate value theorem. I'm going to write it very much the same as this. Maybe just a little different. Okay, here we go. Suppose the function is continuous on a closed interval a, b, and n is any number. I use the k, any number between f of a, f of b, where f of a is not equal to f of b. Then there exists a number c in a b. See, this is closed, this is open, such that f of c is equal to n. I like this one for algebra. I like it better. Okay. Same as the only thing is different. Look. The only thing different, I wrote exactly the same. Suppose f is continuous on a closed interval a, b, and let k be any number strictly between, I'm going to write this for you. Write this one, actually. Write it right here. If you want to, you don't have to. Don't be shy. Right, book is good. But I like a little bit more explanation mine. I said, they didn't say closed interval. They show this one. I said the closed interval, this one. And let k, this is n, is okay too. K equal to, book has a k, okay. I have a, the book has an n, I have a k. Put an n, anything you want. Okay, and then it says any number strictly between f of a and f of b. This is a f of a, this is a f of b, okay, and a c is between a and b. Then there exists a c is right here with the red. in the AB such that f of c is equal to k. Book has an n. That's the only difference. I like the closed interval and strictly between these two. Strictly, I like the added couple of English word. Okay? The same as a book. You don't have to worry about it. It's the same thing. All right, here we go. Let's do this together as a team. But pay attention to this. It says f of a and f of b. Pay attention to this. It's a f of between f of a and b. Okay. Sometimes I like this one. What are we saying? This is the one I like. Look, in algebra, we say this is a, this is a b. I'm going to ask you a question, answer it. Don't write it. You don't have to. Is it a less than b? Say yes or no. A to the left. Do you agree? And watch. Okay, I'm sorry. Okay. Ignore this piece. I'm going to ask you a question. Okay. I'm going to ask you a question. This is the A right here. Okay. A goes in, f of A comes out. Look, this is the Y. Y is the same as f of B. B goes in, f of B comes out. I'm going to ask you one question, two questions. I already asked you one. Is it A less than B? Say yes or no. Yes, right? What is a sign, S-I-G-N? What is a sign of a f of B? What is it? Sign of a Y here in this area. Positive or negative?
Positive.
Positive is above the x-axis, above the x-axis. The sign over here, which is a Y, is positive or negative?
Negative.
I like that. Are these two opposite signs? Yeah. So if you connect these two Y together, don't you think so? It has to go to graph of has to go to x-axis. Look, simple. This is the Y positive, and this is the Y negative. I'm going to ask you this. If you connect these two Y, is it going to go through the x-axis or not? Say yes or no.
Yes.
Yes, look, it did. At this point, what is the value of Y in that point? What is the value of Y in that point? Because it's the x-axis, Y is 0. Do you agree? Say something. I'm going to call this C. I'm going to f of C is equal to 0. Here in the book says f of C is equal to a number. N can be a 0, N can be any number. It's okay. This is interesting. But intermediate value IVT says we can find a number. I mean, we know there's a number between f of A, f of B. But can we find them? No. Why not? Very difficult. Very, very, very difficult. For example, how would you, with the hand and a calculator, if that was radical 3 is a number 1 after 1, they have trillions of decimals. How are we going to find that exact number? No way. So, but we know there is a number there. We know between A and B there's a C. We know that, and that makes it is an N. Can we find this C? No, but we know it's there. We know it's there. We know it's there. That's a good thing about it. We're done. When LVT said it's there, you say it's there, you don't have to worry about it. Let's do a couple thousand examples for this. I brought from another book nice examples because this book doesn't have a lot of good examples and has only has a few numbers, only 4 of them. I'm going to do 54 for you, and I do more examples. So 54 from our book says ln x equal to x minus radical x. They give us between these two. That's a and B. This is a, this is a B. Did I write this right? Did I write the problem right? Very good, thank you. What it says? It says that problem says, what problem said? It says use intermediate value theorem to show that there is a root of the given equation in a specific number. Everybody, how many ways you can say this? What is that? That part has a name. What do we call them? I'll give you the first one: x-intercept, root, solution, factor. Has 7 different numbers. 7 different numbers. It says make sure there's a root between A and B. This is a, this is a B. This is A, this is a B. Let's prove this. Number 54. Here we go. Let's prove it. This is very easy, by the way. Don't panic. This is easier than the continuity I show you. We're going to write this one in a function form. I'm going to bring this side, ln x minus x plus radical equal to 0. Okay? I'm going to write this one in this form. I'm going to call this, I'm going to call it f of x is equal to ln x minus x plus radical x. Okay? Question number 1. Is this continuous? Is it continuous on bracket 2 and 3? Say yes or no. Say yes or no. You don't have to be correct. I am going to, this is condition number 1. I am going to help you with that. Anybody remember what is the graph of a ln x? Right here. And this is 0 to infinity. This is continuous. Do you agree with me or disagree? This is continuous from 0 to infinity.
Agreed.
X is continuous from 0 to infinity. Do you agree?
Agree.
That's a graph of x. And graph of a radical is right here, from here, here. It is continuous from 2 to all of this. Are they continuous from 2 to 3? Say yes or no.
Yes.
Yes. All the graph of them. You should know that. You must know that. And then plug in f of 2. 2 is right there. I get 2 from here. Do you agree with me? That would be ln 2 minus 2. Do you have a calculator? This is the only one I'd like to have answered in a decimal. And I'm going to plug in 2 numbers. They give it to us. F of 3. ln 3 minus 3 radical 3. Okay, could you, I'm hoping that these two have an opposite sign. If these two has an opposite sign, could you do me an honor and tell me what is the first one? One of you calculate the first one. What would you got? What did you get? You don't have any calculator with you? Okay, thank you for helping. I appreciate that. You guys are very nice to me. Here we go. We want this to be different. The signs we want to be different. Go ahead and write them down, please. Do you all of you have do you have a cell phone with you? You do? Okay, Nayana shaking head. She's good. Samantha is good to me. The rest of you, you don't even move your head. All right. Take a snapshot of this. Get your camera ready. This is another version of it. I don't like the version in our book because they say it, but they don't use it. Here we go. Take a picture of this. Take a picture of it. This part. Then can you see the whole thing? Take a picture of that part. Right there. I like this better. This is an algebra and pre-calculus I taught yesterday. Look, it says A is less than B. F of A, F of B has an opposite sign. Opposite sign. Hey, they have this is a negative and this is a positive. Do they have opposite sign? It didn't say that in our book. Opposite sign, and there exists at least one real zero C between A and B, such as P of 0 is a 3. I'm going to prove it to you that P of that 2 is equal to 0. See? This part they didn't say. This part says P of C is equal to N. That N can be 0. Did you take a picture of it? Can I move it? All right, good. Good. Okay.
I have a question.
Yes, sir.
All right, so it was saying for the intermediate value theorem, it says that like f of A and f of B can't be equal. Can they
No,
be the sign but not the
no,
same
cannot
number?
be equal. One of them they have to have a different sign, and A has to be less than B. If they were equal, then we will not have a. If they are equal, then we will not have interval.
No,
Look at this. See,
mean,
if it was
like,
equal, there would be 0. Am I right?
yes.
So we
I
have
meant like if f of A was like equal to 1 and f of B was equal to 2, wouldn't those still not be equal to each other but have the same sign?
that's a calculus. They say that is okay, and calculus is okay. Then it's a calculus says if it was not a 0, if that doesn't have opposite sign. Look here, I don't have opposite. What this is a positive. Is this Anthony?
Yes.
Anthony, there's a positive, right? Above the x-axis.
I'm confusing myself. I forgot that f of A and f of B are on the y-axis, not the x.
F of B, F of A are y's,
Yes.
and A and B are x's. Okay, look, I'm gonna write it for you here. I shouldn't do that. This is the x, and this is the y. Don't worry about it. Don't worry about it. You're still cool in my book. Okay, let me finish this real quick because I don't want to go over the time. If you have any question after class, I'll be there for you. I like this class. You guys are all nice, and I want to help you as much as I can. So what did I do here? So watch this. Is it the f of 2 positive or negative?
Positive.
Positive means greater than 0. Am I right?
Yes.
Okay. And f of 3 is it positive or negative?
Negative.
They're less than 0. Do you agree?
Yes.
So these two have a opposite sign. Then we say there is, I'm writing exactly like the book explained, like exam from the book. There is a number, right with me, number C in, don't forget that. The theorem says, watch my hand, 1 second. Continuous in a closed interval, and C has to be between these two, not at the end point. No, open. In a C, what is ST means? Such that f of C is equal to what? 0. But, write it down. I'm going to tell you something important for exam. But if you say this, I'm going to tell you, I'm going to give you 0 on the exam. I'm going to say, you know what? You told me there's a 0 here. Could you find this C number for me to make this function 0? You cannot. It's very difficult. In order to protect yourself, in order for you to protect yourself, write this one. By I V T. Then I give you full credit right away. You have to write this. If you don't, you have to find it for me, which you cannot. There's no way. Thus, or therefore, thus, therefore, thus, there is a root or solution or answer of the equation ln x minus x plus radical x equal to 0. Okay, or ln x is equal to x minus x in the interval 2 and 3. Problem started like this. So you got this, or look at original problem. Here we go. Okay, they're saying that this problem, these guys, at one point, they have a root between 2 and 3, and the roots are equal. Or if you go through x-axis are 0.
Is root just another word for solution?
Yeah, has 7 numbers in it. Look at this. Root, it is the answer. Root, answer, solution, x-intercept. They have 2, 3 more. I use, there are 6 of them, excuse me. 0 of the polynomial. The 0, 0, root, factor, solution, intercept, x-intercept. What is that I wrote? Root, factor, solution, x-intercept, I-intercept. What is that one? I forgot.
I think it was the 0.
0, thank you. I appreciate it. It's a Z. It's Antonio Banderas. It's a Zorro. It's a Z. Z, root, what is this one? Factor. Just look at this. If I tell you x minus 2, x plus 3 is equal to 0, these are the factor. It means 2 is a root, negative 3 is a root. Or if you know what I'm saying, they have 1, 2, 3, 4, 5 of them, I remember. Okay. 0, root, factor, solution, intercept. They all mean the same thing. Do you have any other questions? I'll do more problem. I do another problem on Tuesday for intermediate algebra. Promise me one thing. What are you gonna do this weekend? You're gonna catch up by Tuesday. We do chapter 1, and chapter 1 is optional again. Don't get confused, but I want you to do it. I give you 5 extra points to it. I open a slot for you in a Canvas for the due date is the exam date. So the thing is, do chapter 1 and chapter 2 all the way to 2.5, finish them before Tuesday. Finish them before Tuesday. On Tuesday, when you come back, you go to MathLab, library, STEM Center, Google, YouTube, friends, relative, anywhere you can, go. Get all your answers and save me 2 of them which nobody can answer. On Tuesday, I'm going to come to class and say, good morning, my class. Do you have any questions? Give me a couple of them. I'll be happy to do it for you. And after class, I do more for you. If you have any question, I'm there for you. I'm not going to leave right now and stay. Otherwise, have a nice weekend. And thanks for being today here. Don't miss the class. Don't be late. Calculus is important. Get an A in this class. Get it over with. Go through pain. It's okay. It's worth it. No pain, no gain. Thank you, guys, all of you. Again, you've been 2 weeks with me. You were wonderful. Okay? Thank you for being so nice and polite.
Thank you,
Peace.
Professor.
Thank you for thanking me.
Bye.
Thank you for thanking.
Thank you.
Thank you for thanking.
I thank you.
Getting there. Just keep that core drive in one piece for a little longer.